When the steel dowel unit is not used, the natural cracking of the concrete is uncontrolled. Temperature changes increase the cracking, destroying the overall strength of the concrete. Because the slabs are not tied together, the pressure of heavy traffic causes them to sink down into the subgrade. And when water seeps down through the widened crack, pumping begins. The inner structure of the highway begins to deteriorate and eventually to crumble and fall apart. When the steel dowel unit is used, the faulting is controlled and held to a minimum. Also, pumping is prevented, thereby preserving the integrity of the subgrade. The concrete stays strong and firmly in place. The dowels hold the slabs in line under temperature changes and also provide a means of transferring the weight of heavy traffic from one slab to the other. Dowel units are economical to ship by rail or truck. They nest easily, and because they are light and compact, they can be assembled either right on the job just ahead of the pavers, or if more convenient, at the contractor's stockpile. The steel plate fits snugly, and the oblique slots keep it from floating in the wet concrete. Used in this combination, the unit becomes a contraction joint. Another important use of the dowel unit is in an expansion joint. Concrete naturally expands and contracts with changes in temperature. Also, solid material sometimes gets down into the joints and takes up space. In time, if nothing is done about it, the slabs will buckle. By inserting a cork or a fiber filler instead of the steel plate, a means is provided to absorb the pressure, and the highway remains intact. With the fiber filler in place, the dowel unit is ready for its job in an expansion joint. The filler allows for the expansion of the concrete due to temperature changes, as well as its growth as it ages. It also prevents foreign material from entering the joint. When the dowel unit is placed in position, a temporary cap is installed over it. This is to protect it against the first rush of concrete in pouring. The cap will be removed before the concrete hardens. In addition, short lengths of tubing are slipped over one end of each dowel, alternating between one side of the joint and the other. Thus, working space is provided within the concrete for the longitudinal movement of the slabs. Thermal changes affecting the concrete cause it to expand and thereby exert pressure on the filler, which forces the sealing compound slightly above the joint. When the pressure is relieved, the compound retracts to fill the void, thus maintaining its sealing property. Concrete paving today is a highly organized assembly line operation. The dry ingredients, sand, stone, and cement, are carefully measured elsewhere and brought to the job by a fleet of trucks. Each batch is dumped into the dual drum paver, which is really a mixer on wheels, capable of handling up to 72 batches per hour. On single-lane paving, the teamwork of men and machines up to an average of 3,000 feet of finished paving in an 8-hour day. The mixer has 2 drums. This design enables the paving operation to proceed without delay, because while one batch is being mixed, another is being transferred to the bucket. The moist concrete is dumped on the roadway just ahead of the spreader. This way of working is called the strike-off method of paving, which means that the first course of concrete is roughly leveled off at the proper height for laying in the reinforcing steel, which is in the form of steel mats. This hinge type is a product of Bethlehem Steel Company. These steel mats are fabricated at a number of Bethlehem's plants and mill depots. The special hinge makes it possible to handle the extra wide mats easily. Because they fold to 8-foot widths, they can be loaded compactly and shipped on trucks or railroad cars. They require a minimum of field storage space, and when folded for shipment, clip base, preventing bracking of the mats. As the mats arrive on the job, they are laid out ahead of the pavers, ready to be placed over the first course of concrete. The procedure for laying the second course of concrete is the same as for the first. The same machinery is used and all operations are repeated, except, of course, the spreader is raised to the new level. In double-lane paving, the slabs may be poured as wide as 24 feet. Most highway steel products are designed to fit either paving method, but in double-lane paving, single bars of reinforcing steel are used in place of hook bolts. These bars provide a center tie between the two halves of the wide slab. In double lanes, the center joint is formed by cutting after the concrete is poured. This gives the double lane slab the appearance of two lanes. Naturally, a double width lane requires twice as many steel mats as a single lane. In both types of paving, the hinged mats are simply unfolded and laid out side by side. Just a simple arrangement of steel rods crisscrossing the roadbed, but when the final course of concrete is put in place on top of them, this strong mesh of steel locks the whole thing together. This is highway steel in one of its simplest but most effective forms. The spreader now goes to work on the concrete mass. This action serves not only to distribute the concrete evenly between the forms, but also agitates it so as to maintain the proper distribution of the ingredients. Whether the road builders are using the double lane method or paving one lane at a time, the basic procedure from here on is the same. Following along behind the spreader is a battery of finishing machines. Each machine has two oscillating members called screeds, which scrape off the concrete at the level of the paving forms. This operation is repeated by a second machine, which closely follows the first. The action of the screeds not only establishes the final grade level of the finished highway, but also consolidates and improves the structure of the concrete near the surface. The last machine in the line is the longitudinal floater. But before this goes to work, the temporary installing caps over the dowel units are spotted and removed. The function of the longitudinal floater is to fill in and smooth out any waves or depressions left by the previous machines. As its name implies, the oscillating motion of this machine is perpendicular to that of the other machines. Thus, the concrete surface is smoothed out in both directions. Then the rough highway is ready for the rear guard of hand craftsmen who follow the road building machinery, craftsmen who put a final finish on the road surface. Any slight wrinkles left in the wet concrete are smoothed out by the hand float finisher. Other men follow with strips of burlap on a wooden frame, giving the surface the proper texture for traffic. Craftsmen finish the edges along the paving form and smooth out the concrete along the joints. There are several ways of curing concrete. In this instance, burlap is placed over the fresh paving and kept moistened until the concrete is set or cured. This prevents the concrete from drying out too fast. When the pavement is completely dry, the joints are sealed, which helps to prevent moisture from getting down into the subgrade and is the final step of the paving process. This section of finished highway with its backbone of steel will be utilized by numberless trucks and passenger cars during its lifetime. It is therefore not surprising that the same type of construction is being used in airport runways, which today need to be more durable than ever before. Planes are bigger than they used to be, they fly faster, and they carry heavier loads. Concrete has been found to best withstand the effects of impact and the terrific heat generated by fuels, such as are used in jet planes. And so the steel and steel products that make today's highways possible also serve today's airways by strengthening the airport runway. No highway is really completed until it's equipped for safety. Wherever there's a curb, fill, or other danger spot along the road, there is a need for protection. Safety beam guardrail is a strong and effective highway guard. The steel posts to which the beam is attached arrive on the job cut to length and properly punched. The special post-driving equipment mounted on a truck drives them to uniform depths. Steel guard posts are easy to align, and they last longer than other types. The beam sections have a shop coat of paint and are ready for assembly when they arrive in the field. Safety beam guardrail is cold formed from strip steel and then punched and sheared to specified length simultaneously. The channel construction gives it unusual strength. After they're formed and punched, the guardrails are finished by being cleaned and given their protective coat of paint. One bolt fastens the rail to any type of post, and a splice assembly made up of a splice plate and bolts secures the beam ends to make one strong continuous steel rail. The flared ends of the rail add to the appearance of the job. Safety beam guardrail gives ample protection because the continuous steel beam tends to absorb impact and distribute it over a wide area. A finish coat of white paint completes the installation, making the safety beam visible night and day. The safety beam guardrail adds to the streamlined appearance of the highway. Another highway safety guard, adaptable for use with wood, concrete, or steel posts, is the cable guardrail. The shape and depth of the offset bracket gives this guardrail exceptional shock-absorbing qualities. The anchor rod is attached to a concrete block buried in the ground. Turnbuckles maintain tension in the cables. This is still another packaged unit of the steel plant. The addition of right-of-way fencing gives further protection to the motorist and to the property owner. Its hinged joint construction contributes to its flexibility, which is as well as its installation. Here is a protective web of steel hung on its supporting self-fastener post, a finishing touch of steel for the modern highway. And so your highway is completed, and steel has entered into every phase of its building. Steel equipment was used in clearing the roadbed and in pouring and smoothing the concrete. Steel buried in the paving and piers reinforces and strengthens them. Steel makes possible the necessary bridges and overpasses. Steel guardrails and fencing are protection to the traveler. In all parts of the country, highways that are so important and necessary to our civilization are being built today with steel. Highways that will serve for many years to come. They must be strong and smooth and able to carry the great caravan cars and trucks and trailers that make up present-day traffic safely to their destination. The modern highway is truly the open road, the broad, pleasant avenue leading to business and creation, and future portends in highway planning and construction.